Hi, I'm Michael. I'm a rising senior at Monte Vista High School, and this is my final milestone for the phone-controlled robotic arm. And my final milestone is having the mobile phone app that I designed in my second milestone control the robot arm itself. Uh, for the second milestone, I had the mobile app send strings through Bluetooth to the serial monitor. Now I'm taking those values and using them to control the servo motors. And to do this, I connected all the servo motors to the ESP32 microcontroller and removed them from the Arduino board that I used before, since the ESP32 supports Bluetooth and allowing me to control the servo motors with my phone remotely. While the Arduino also supports Bluetooth, it requires an extra module in order to implement the functionality, while the ESP32 has Bluetooth built into the microcontroller, which adds convenience. I then implemented my code from the first milestone where I control the servo motors using input to the serial monitor, except that now it takes in the values that the mobile app sends and uses those to control the motors. I also added an ultrasonic sensor to the robotic arm, as well as the functionality to have the claw open and close whenever an object gets within range of it. And in this case, I set it to 3 inches. When it's within 3 inches, the claw will close. Let me perform a demonstration right now of the robotic arm. So, using the phone app, I have the sliders on here, and I'll open the claw, move the arm back and forth, and move the waist, have it move right and left. And for the ultrasonic sensor right up here, I'll demonstrate its functionality. See, it automatically closed when the screwdriver went in between the claws. I'll do that again. Yeah. One issue that I had during this milestone was that these servo motors weren't turning all the way from 0 degrees to 180 degrees with the ESP32 connection. I found that this was due to incorrect values for 2 parameters for the servo's attach method. The first is the pulse width for the lowest position, while the second parameter is the pulse width for the maximum position. Each servo motor has different individual values, even servo motors of the same brand potentially. And for maximum compatibility, I fine-tuned the values and eventually got them to turn all the way around. I got the servos to turn all the way around. Yeah. And for this project as a whole, I first got the servo motors turning using breadboard connections and controlled it with an Arduino with the serial monitor. And then I switched from Arduino to the ESP for a more convenient Bluetooth connection, created a mobile app with the MIT App Inventor, and connected this to the ESP32. This sends strings like S1, S2, S3, S4 for each motor to decide for the program to decide which motor to turn, and the position value to turn the servo motors to. And throughout this project, I came to really enjoy both the building and the software coding aspects of it, such as assembling the arm itself. I really enjoyed that. And as well as creating the mobile app, I found the MIT App Inventor to be really intuitive and a really nice interface, and I found the process of designing and coding the app to be really enjoyable. And because of this experience at Blue Stamp, I'll be sure to look more into mechanical as well as computer science aspects into the future. And that's about it. Thank you so much for listening.